Day 25, page 655, problem number 56. Let's draw the schematic diagram here. All right, and the switch doesn't really matter that much. That's just for turning it on and off. But now we want to simplify this, and there are some shortcuts. But first of all, we have a 3 and a 1 microfarad in parallel. When you combine those, that makes 4 microfarads. That's what makes this problem pretty easy. If you drew that diagram, it would look like this. 2 4 microfarad capacitors in series. Since they're equivalent, right, if you combine them using the 1 over C total rule, if you were asked to do this, but we really don't need to do it, but I will anyway, the final circuit simplified, if you were asked to simplify it, which you may be asked to do, will be a 2 microfarad capacitor with a 12 volt potential difference. And you can figure out the charge on the 2 microfarad capacitor. But going back, that last circuit I drew, we actually could take a shortcut. Because they're 2 equal capacitors in a very simple circuit, they're both going to be 6 volts, the potential difference. And bottom line, it has to add up to 12 volts, and since they're equal, you just take 12 divided by 2. But if they weren't equal, like if you had a 2 and a 4 microfarads, the 4 microfarads would have twice as much potential as the 2. Or you could figure it out proportional, or what you could do is go to that final diagram and figure out what the charge is. Like in this last one, it would be C equals Q over V. C being 2 microfarads, that's just 2 times 10 to the negative 6th, which I don't have space for, so micro means 10 to the negative 6th, equals Q over V, which is 12. So the V is 12, I forgot to write that there, but 12 times 2 would give you a Q, a charge stored of 2 times 12 would be 24 microcoulombs. If they asked you to do that, because you might be asked to do that, just to kind of refresh your memory, that would be the charge stored on this final replacement capacitor. But what is also true if I worked a problem backwards, and once again this would be more critical if you had 2 capacitors in the blue diagram that were not equal, but in this case, what is true though, in series you always have the same charge on both. You don't always have the same voltage, potential difference. These do just because they're the same capacitor. But what has to be always true is they will have the same charge. They're both going to be 24 microcoulombs. No matter what their charges are, they have the same, no matter what their capacitance is, they both have 24 microcoulombs, which you could have figured out by using C equals Q over V. But let me just take this a step further to show you a situation going back to the first diagram with the 1 and the 3 microfarads. What's true there now is they each have 6 volts. It's not additive. But what is the charge on each one? So check this out. They are each 6 volts. Let me just use blue. The potential difference. So in parallel, whether it's resistors or capacitors, they always have the same potential difference. And now I use C equals Q over V to get the charge stored in each one of those. So basically, if you look at the equation, I'll just do one of them and you can figure out the other one. But the equation is C equals Q over V. You can pretty much do this one in your head. But for the, let's say the 3 microfarad capacitor, that's a 3 microfarad equals Q, the charge stored on it, divided by the potential difference, which is 6. So Q for that guy is 18 microcoulombs. So the charge stored right here is 18 microcoulombs. And if you did the same thing for the 1 microfarad capacitor, you would get 6 microcoulombs of charge stored. Another check on this is if you take those final 2 charges, the 6 stored on those capacitors, the 6 microcoulombs plus the 18 microcoulombs gives you the 24 microcoulombs for the replacement capacitor for those, the 3 and the 1, if you look in the blue diagram. So it's all consistent. Then you could be asked for how much energy is stored on each capacitor. For example, one of the more basic equations for the energy stored, U equals 1/2 Q, technically delta V. Usually just say 1/2 QV. but if you just plug in Q and V for each of the capacitors, that's how much energy is stored on each one of them in joules. There are other equations you can use for energy stored if you mix and match some of the equations, but that's one of the most basic equations there circled in blue.